Most data mixing methods assume someone already sorted the corpus into groups. Web pages here, code there, math over there, then the mixer just tunes the ratios. But here's the catch. The choice of groups decides everything the mixer can express, and every existing label, provenance, topic, format, even flat embedding clusters, commits to one semantic axis at one single granularity. Want finer resolution? Rebuild every label from scratch. This paper argues the real bottleneck is not the mixer at all, it is the label system. Fix that once, and the whole hierarchy comes for free. Hermes. A data-derived labeling substrate. 2 parts. First, a learned semantic transform maps each document into a space where semantic similarity is geometry. Second, 3-stage residual vector quantization, RVQ, the same residual codebook trick that compresses audio, annotates each document exactly once into a coarse to fine code. Read the full code, you get the finest grain. Read only the prefix, you get a coarser bucket. One annotation, every granularity, up to about 130,000 cells. The mental model. Think of each document's code as an address with depth. Stage 1, the root category. Stage 2, a refinement. Stage 3, the finest leaf. The prefix length is a zoom dial. Zoom out, you see a handful of broad domains. Zoom in, you resolve fine subtopics. No relabeling, no re-embedding, no rebuilding. The same annotation serves a coarse sweep and a fine-grained dissection. That is the substrate. A reusable hierarchy you navigate, not a label set you commit to and then pay to escape. The first chart, and an honest one. At coarse granularity, Hermes sits on a plateau with k-means family methods on every standard clustering metric. Same quality clusters, so the contribution is not a better clusterer. There is no clustering breakthrough here. The contribution is the substrate itself, the hierarchy that k-means, flat by nature, simply cannot offer. Remember that. The win is the structure, not the buckets. The counterintuitive lever. Data mixture design is not one problem at one resolution. It is a different problem at every zoom. The hierarchy exposes interactions fixed granularity pipelines cannot even test. At one prefix length, a combined stage 2 rule, equal coverage across subbuckets against size proportional top 30% quality, lifts a 16-task capability average by 0.0253. Real, measurable, repeatable. At the next finer level, the exact same rule loses its edge entirely. Why the rule breaks? At the finer prefix, each candidate pool contracts about 5 times. The size proportional quality rule starves. Too few candidates per bucket to fill a budget without scraping the bottom, so the very rule that won one zoom level up now underperforms. One annotation, 2 granularity regimes, opposite optimal policies. That is the kind of interaction a flat label system is structurally blind to. You cannot find what your labels cannot express. The testbed. 1 billion parameter model, 25 billion pre-training tokens. 16 downstream capability tasks, macro averaged. The hierarchy does not hand you a single best mixture, it hands you a space to search. Each prefix length is a different lens on the same corpus, and the right mixing rule turns out to depend on which lens you hold. Fixed granularity pipelines pick one lens, forever, and never learn that the optimum moves as you zoom. 4 honest caveats. First, the clustering itself is unremarkable, a plateau with k-means. Second, the headline gain, 0.0253 macro capability, is modest, not a leap. Third, the contraction effect is measured at one scale, 1 billion parameters, 25 billion tokens. Whether it sharpens or washes out at larger scale is open. Fourth, RVQ codebooks still need fitting. The substrate is cheap to query, not free to build. Honest framing. The reframe is the contribution, not a benchmark win. Stop choosing among fixed label sets. Annotate each document once into a coarse to fine code and navigate the hierarchy. Hermes, a learned semantic transform plus 3-stage residual quantization. One annotation, every granularity, up to 130,000 cells. The data mixing bottleneck was never the mixer, it was the labels. Reframe the problem and the optimal policy stops being a guess and starts being a function of how deep you choose to zoom.